Welcome back to my YouTube channel. In this video, we are going to see about counterflow cooling tower. First, what's meant by a counterflow cooling tower? A cooling tower is nothing but removes the excessive heat from the water. The reason behind the counterflow cooling tower is water comes down and the air goes up. So both the air and water counter each other. So it's called as a counterflow cooling tower. Bottom, we have a picture of a counterflow cooling tower. Let us look into it. We have a cooling tower fan, and we have a water distributor, and we have a column fillets, and we have a hot water inlet, and we have a cold water inlet. We have drain port and overflow, and we have a makeup water level. Let us look at the working of a counterflow cooling tower. First, warm water from an industrial process is distributed over the fluid media inside the tower. Actually, a warm water will be distributed at the top of the fillet media, and the air is drawn or forced in a vertical upward through the fluid media, counter current to the falling water. As we know, water comes down, and the air will be reacted at the top. So both the air and water will be counter each other. So heat exchange. As air passes through the film media, heat is transferred from the warm water to the air through evaporation or converts a exchange. And actually, it's a form where the hot water will convert into or warm water will convert into a normal temperature water. The water loses the heat and is collected at the basin of the bottom of the tower. As you know, at the bottom we have a base which will collect all the cooling water at the bottom. And the cool air will exhaust through the cooling tower. Let us look at the pictures which will help you understand clearly. At the second picture, I shown where hot water is inlet. It goes up and is distributed to the column fillets where fillets comes down and the bottom where air goes up. So both the water and air will be encounter each other, and where it will be losses heat and it collected in the bottom, and it goes to the cold water outlet. And we have overflow which helps to find the level of the basin water, and we have also have a makeup water port which helps to add up a water. But because of an hot water inlet is it come across the various process where it's operated in inside, it gets water level will be less or volume will be less. It comes to hot water comes up and it vapored, so volume of water will be less, it comes down, so we have to make add on makeup water to run the remaining process of cooling water. And the first image you can see how the water and air will become to each other. The application of both the cross flow and counter flow will be a similar, but it has a difference in their advantages and disadvantages. Let us look at the advantages of counter flow. It allows for efficient heat exchange due to the counter current flow of air and water, optimizing cooling efficiency or performance. This because of both air and water have been counter each other, so the efficiency of cooling will be high compared to the cross flow. The design allows for a lower pumping power requirement, contributing to the energy efficiency. As we know, it's a very lower pumping power. This counterflow actually designed for the less power consumption and efficiency of cooling performance as well. It is less prone to the ice formation in a cold climate compared to the cross flow tower. Actually, it is very less chance to the ice formation in a cold climate or a cold countries where ice formation will be occurs within a second a day. And as well as it is a more compact design, make them suitable for installation with space constraint. Let us look at the disadvantages of a counterflow cooling tower. While generally a more compact than a cross-flow cooling tower, but a counterflow cooling tower may still require significant space. As you know, compared to the cross flow, counter flow will be space will be a less requirement, but still it need a little bit more space for the installation and processing. The internal component for the maintenance can be a more challenging compared to the cross flow tower. For the maintenance in the internal components, which will be challenging compared to the cross flow. If not properly maintained, the fill media in a counter flow tower, it can be prone to contamination and biological growth. It's nothing but fillets media has a little bit less lifespan. It's due to the salt formation in a fillets, which will be affect the cooling efficiency of a cooling tower. So it need to be properly maintained and it properly checked for the process. In certain condition, there may be a risk of air recirculation. It reduces the overall cooling efficiency. While you compare to the cross flow, where air will be sucked out to the exhaust fan, but in the counter flow, where air will be recirculated within the cooling tower, so it may be reduce the overall cooling efficiency of the components. And as well, the intel capital cost of installing a counterflow cooling tower can be relatively high when you compare to the cross flow. It comes because it has a huge advantages in processing, so it little bit costlier. But while you compare to the natural cooling system or a cooling tower, which will be a very huge, large area required for the installation and construction, it will little bit more costlier while you compare to the cross flow and the counter flow. So that's all about both the counter flow and cross flow of a cooling tower. I'll see you in the another video. Thank you and bye bye.